We're going to do a do now. We're going to take some notes on properties of acids and bases and discuss what is an acid and a base. And what I would like you to do after this lecture is complete the graphic organizer that's linked in Canvas in the module underneath this lecture. Just a couple other things that you should keep in mind over the next week. Vocab. The vocab assignment is going to be due on April 2nd. You're going to complete the graphic organizer. You should also see a couple more lectures coming up, as well as a lab on acids and bases. What I would like you to start with is a little bit of brainstorming. See if you can think of two acids or two bases that you've encountered in real life. It's usually easier to think of two acids than it is to think of two bases, but maybe think back to your middle school days when you first encountered acids and bases. Here's a few that I just pulled up. Common ones for acid, lemon or any citrus. A lot of the foods we eat actually fall into the acidic category. Common medications, anything with salicylic acid, like a face cleaner for acne or aspirin, have salicylic acid in them. Common bases, a lot of cleaning materials tend to be bases. Anything that you would call a soap usually is in the basic category. One of the topics we're going to talk about later this week is pH. pH is the scale that we use to determine how acidic or basic something actually is. It's a scale of 0 to 14. 14 being the most basic, 0 being the most acidic. A pH of 7 is neutral. The most common neutral substance is water. But as you can see, this chart here has a few normal cleaning products such as bleach. Again, cleaning products tend to be basic. Soaps tend to fall on the basic side. And again, vinegar and acid, toilet bowl cleaner, also an acid, fall in the lower range of pH. Here's really the important part of today's lesson. Definition of an acid, so actually being able to identify acids and bases is a big part of what we're doing today. Arrhenius acids. Arrhenius is a scientist. His definition is any compound that has hydrogen and can dissociate in water to fill a solution with hydrogen ions. If it produces hydrogen ions, H+, in water, an aqueous solution, then it is considered an acid. What gets a little more complicated is there's a few different ways to refer to hydrogen ions, so there's some terminology coming up here. Those few ways is, first, the one we're used to, a hydrogen ion, H+. H+ can also be described as H3O+, so this is when water, H2O, takes on an extra proton, and it makes the hydronium ion, H3O+. You probably have seen this before on table E if you've looked closely, but this is another way to describe an acid. Hydrogen ions can also be called protons, again because the only subatomic particle here is a proton. Maybe a neutron, but the only charged one is a proton. So you can also call H+ a proton. A couple examples that we can talk about are, we have hydrochloric acid, HCl, HBr, and then this one, a little different. If you see an H, so COOH, with the H at the end, this is also another acid identifier. So you're looking for compounds starting with an H or ending with COOH. I would write that down if I were you. So to identify an acid, compounds that start with an H and end with COOH, or also anything listed on table K in your reference table. Another definition of an acid is acids are proton donors. So again, anything on table K, and a proton donor it's like what it sounds like. It's going to donate or give up a proton. So if we add hydrochloric acid, HCl, to water, it's going to protonate or dissociate into your proton and your chloride ion. It has donated this H+. Common properties of acids include, again, starting with H or ending with COOH. Those are your identifiers. But they taste sour or tart. So again, any foods that you commonly associate with sourness or tartness, they're probably acids. They tend to sting or burn your skin. If they're particularly strong, they definitely will burn your skin. So in the lab, you're going to be wearing goggles or gloves when working with most acids. Aqueous solutions are still electrolytes. So again, these are things that dissociate in water. We have mobile ions. They can conduct electricity. And we'll talk about this later, but they cause indicators to change color, and we'll talk about what an indicator is in a lesson later this week. As far as chemical reactions go, they react with metals to produce hydrogen gas. We actually saw that in our single replacement lab. Anything that produced bubbles or hydrogen gas was actually a metal reacting with an acid. And then you're also left with salt as your product. And they always have pHs less than 7. Bases are pretty much your opposites of acids. So bases, by definition, have to have a hydroxide ion, or OH. They are substances that when you put them in water, they're going to dissociate, and you're left with, instead of a proton, a hydroxide ion. For example, sodium hydroxide is a base. Again, you're looking for that OH, or anything that's listed on table L in your reference table. Bases can also be described as proton acceptors. So instead of donating, like we saw with our acids, they will take that proton that an acid has donated and accept it. Common properties of bases. So again, you're identifying OH in the chemical formula in order to identify a base. They taste very bitter. They tend to feel slippery, so like when you have oil or soap on your fingers, it's that feeling when you have a base on your hand. These are also electrolytes. You have a substance dissociating in water to break apart into ions. They can conduct electricity because, again, there's mobile ions in solution. And they will also cause indicators to change a certain color. And they have pHs greater than 7. So 8 to 14 range on our pH scale are basic. Common acids and bases, again, are given to you in your reference table, table L and table K. If you need names of bases, or if you forget how to identify an acid or a base, these should help you out. So again, we look for those OH in common, or for bases, excuse me. Or one that does not follow that pattern is ammonia. NH3 is the only other substance that you need to recognize as a base but does not have a hydroxide ion in it. Again, we come to table K. Most of these acids start with hydrogen. So again, they're going to produce those protons when dissociated. Our exception being our COOH ethanoic acid down here that you